warahmatullahi wabarakatuh, and a very good morning. Okay, today we are going to explain about separation of selected flammable compounds by using gas chromatography. So what is gas chromatography? Okay, what is meant by gas chromatography? Gas chromatography is a common type of chromatography used in analytical chemistry for separating and analyzing compounds that can be vaporized without a decomposition. In some cases, gas chromatography can be used to identify a compound. The objective of this experiment is to separate and identify components of a mixture of selected analkane by using temperature program of gas chromatography. The existence of selected analkanes will be identified in an unknown sample. This is the schematic diagram for gas chromatography. As we can see that the carrier gas will carry our sample across the column after injection. It will be later on passed to the detector, which will be providing us the signal in chromatography.
Next, I will explain about the mobile and stationary phase in gas chromatography. Mobile phase is where the mixture of a gas sample is dissolved in a fluid. The fluid is usually an inert such as helium, argon, and nitrogen gas. While stationary phase is where the mixture of a gas from the mobile phase is going through the holding structure. The holding structure is usually a high volume polymer coating the capillary column.
What is split injection and splitless injection?
Well, first, split injection is the simple method which is ideal if only a small amount of component presents and it is not for a trace analysis. So typically, the ratio of this injection is 10 to 1 or 50 to 1. This injection is used for a small proportion of the sample which is transferred onto the column. Well, the second one is split injection. It is suitable for sample containing trace compound in low concentration because necessary to transfer as much as possible onto the column to increase the sensitivity. So, the lower valve is closed at time of injection and only a small spectrum purge follow is used. Injection takes place into heated zone over a period of time which is 20 seconds to 30 seconds. So that all sample is transferred to the column. After a predetermined period, which is 40 to 60 seconds, the lower valve is open to purge the injection port and to prevent residual sample from causing fading of the peak.
Everyone, next I'll be explaining on what happens after the injection of the sample to the system. So before beginning a separation, there are certain parameters that are needed to be set accordingly. So first, we have to set the flow rate to 1.3 milliliter per minute, and then we have to set the temperature of the oven accordingly with the range of 40 to 150 degrees Celsius, where it is held in the initial 5 minutes and the final 5 minutes. Temperature of the inlet port is also set to 300 degrees Celsius to ensure that the sample is fully vaporized. About 1 microliter of sample is taken up in a syringe and then it is injected into the injector port. For gas chromatography, the samples are separated based on the mobility of the gases, thus carrier gas is used. In this case, we use helium as our carrier gas. Helium gas acts as a driving force to push the sample gas through the tube of columns. So the carrier gas should be inert to avoid any reaction with the sample. In the column, there will be interactions between liquid stationary phase and the vapor analyte. This is when the separation of hydrocarbon occurs. A detector is placed at the end of the tube to detect the amount of components fall inside the sample. Detected samples will be shown as a peak in the computer.
moving on, I'll be explaining on the graph on the chromatogram. To doing the separation of selected flammable compounds, we need to identify what hydrocarbon present in our unknown sample. In order to do that, we have to run through a simple procedure. First, the standard are injected into the system. Standard are run once into the system, where consisting of C7 to C14. The peaks and the retention time are noted on the chromatogram. Next, an unknown sample is run through the system, yielding us the second graph. In order to know what hydrocarbon present in our unknown sample, we run the system again, but this time we spike our unknown with a small particular of unknown standard. From comparing all these three graphs, we will be able to know the difference in the peak and therefore confirm our identity of our sample.
In graph 2, we will compare similar retention time with standard in graph 1. By noticing the increment of peaks in graph 3, we can confirm the identity using the retention time relation. Hence, we conclude that the hydrocarbon present in the unknown sample are C8, C9 and C13.
Moving on to the next, I would like to explain about the relationship between the polarity and its retention time and the relationship between the molecular weight and its retention time. First, I will start with the polarity. Polar compounds usually have a higher polarity and therefore they have a stronger affinity towards stationary phase column, and hence the retention time will be longer. Meanwhile, for non-polar compounds, they will not stay in the system and they will easily exit the stationary phase, and therefore for the non-polar compounds their retention time will be slower. Okay, that shows that the polarity is directly proportional to the polarity of the compounds. Secondly, it's about the molecular weight. The molecular weight increases. As the molecular weight increases, the boiling point also increases. And when the boiling point increases, the interaction will be stronger to break the bonds between the polar compounds, and therefore the retention time will be longer. So this also shows that molecular weight is directly proportional to the retention time. And thank you very much.
So that is how gas chromatography works.
That's all from us.
See you soon!